Alright guys, so today's notes are on constant rate of change. We're getting prepared to start looking at linear equations and learning how to calculate slope. So, our vocabulary says relationships that have straight line graphs are called linear relationships. So, linear relationships. The rate of change between any 2 points in a linear relationship is the same or constant. A linear relationship has a constant rate of change. So constant rate of change. Alright, so let's begin looking at our example. It says the height of a hot air balloon after a few seconds is shown. Determine whether the relationship between two quantities is linear. Remember we said that linear means making a line. If so, find the constant rate of change. If not, explain your reasoning. So let's look at our table. If you go from the number 1 to 2, notice that we add 1. It looks exactly like our homework from this week on Mobius. If you go from 2 to 3, you add 1. If you go from 3 to 4, you add 1. Now let's look at our output, the height of the hot air balloon. So from 9 to 18, we're adding 9. From 18 to 27, we're adding 9. And then from 27 to 36, we are also adding 9. This means that as the number of seconds increases by 1, the height of the balloon is increasing by 9 feet. Since the rate of change is constant, meaning we've got the same thing time after time, this is a linear relationship. So our constant rate of change is 9 over 1. And so as you see, we just took our y value and our x value and we made a fraction with it, and our fraction was y over x. This means that the balloon is rising at a rate of 9 feet per second. So let's try a few on our own. Our directions say to determine the relationship between two quantities described in each table and see if it's linear. If so, find the constant rate of change, and if not, explain using reasoning. So let's look at our greeting cards. First, let's start with our x. So our number of cards to go from 1 to 2. So 1 to 2, we're adding 1. To go from 2 to 3, we're going to add 1 as well. And to go from 3 to 4, we're also adding 1. Now let's look at our y values. $1.50 to $3. To go from $1.50 to $3, we're going to add $1.50. To go from $3 to $4.50, we add $1.50. And to go from $4.50 to $6, we're also adding $1.50. Because we have the same number over and over again on both sides, we know that this is going to be linear. And we know that because our rate of change is constant. And our rate of change is going to be 150 over 1. Because that is our y over our x. And so this tells us that greeting cards cost $1.50 per card. Excuse my handwriting. It's looking a little ridiculous today. So let's look at the second example. Party table rentals. So the number of tables as it relates to the cost. So to go from 1 to 2 tables, we're going to add 1. To go from 2 to 3 tables, we're adding 1. And then to go from 3 to 4 tables, we also add 1. Now let's take a look at our costs. So to go from 10 to 18, we would have to add 8. To go from 18 to 24, though, we add 6. And to go from 24 to 28, we add 4. Notice that those numbers are not the same on our y side. We've got an 8, a 6, and a 4. Because those numbers are not the same, we can say that this is not linear. And the reason it's not linear is because our rate of change is not constant. Let's take a look at two more examples. Our next example is about donuts. And we're talking about donuts bought by the dozen. So, to go from 2 to 4, we add 2. To go from 4 to 6, we add 2. And to go from 6 to 8, we also add 2. Now, although that number is not 1 like we've had on all of the others, it's still a constant number. So now let's look at our cost side. If I want to go from 325 to 650, I add 325. If I want to go from 650 to 975, I add 325. And to go from $9.75 to $13, I add $3.25. Because all of these numbers are the same on both sides, we know that our relationship is linear. And the reason we know it's linear is because we have a constant rate of change, and our rate of change is 325 over 2. Let's look at our last example. Our last example is about running. And we've got time in minutes as it relates to distance in miles. If we take a look over here, we've got going from 15 to 30. To go from 15 to 30, you'd add 15. To go from 30 to 45, you'd add 15. And to go from 45 to 60, you'd also add 15. All right, let's look at our y values on our distance side. So to go from 2 to 4, we would add 2. To go from 4 to 5, we add 1. And 5 to 6, we would also add 1. Now notice that we did add 1 on 2 of our occasions, but after that, before that, we added 2. Because we don't have the same number all the way down our y side, we can say that this relationship is not linear. And the reason it is not linear is because our rate of change is not constant. All right, thank you guys for tuning in. Please be sure to watch the slope video and answer the questions on the back of this note sheet.